Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our course. In this lecture, we are going to do an introduction to blockchain. All right, first let's talk about Solidity, which is the programming language that we're going to be coding with in this course. Solidity is among the most popular and contract-oriented programming languages. It is for writing decentralized applications on the Ethereum blockchain, and we're going to talk about what is a decentralized application, what is the Ethereum blockchain, and more in this section. What can you do with Solidity? Well, you can write secure, production-ready smart contracts from scratch for decentralized applications on the Ethereum blockchain. The blockchain technology was created with Bitcoin in 2008, and its number one priority is to establish trust between two or more parties without needing any intermediaries for transactions. And with Bitcoin and blockchain came a new era of programming. Ethereum is one implementation of blockchain. There are many different types of blockchains. Ethereum is very popular. It is open source, public, and a distributed computing platform. You can deploy smart contracts on the Ethereum blockchain if these contracts are written in Solidity. As well, Ethereum supports other programming languages as well for writing smart contracts, but Solidity is the most popular. With Ethereum, you can build a decentralized application and deploy it on the blockchain. A smart contract is a small program, and developers like you and I can define the rules of the trust that we intend to code. Smart contracts cannot be changed once they're deployed on the blockchain, and this makes it hard to program smart contracts and predict errors beforehand, but with testing, we can write efficient smart contracts. And in this course, we're going to learn how we can create smart contracts. And you'll see that it's not as hard as you may think. A blockchain is a time-stamped series of immutable transactions where a record is not owned by any one entity. A blockchain is managed by a cluster of computers that use special algorithms. A blockchain consists of a network of nodes. So a blockchain is like a decentralized person-to-person network of nodes. Each node shares the same copy of data, known as a digital ledger, and each node uses the same algorithm to reach a consensus. Later on in this section, we're going to talk more about what is decentralized versus centralized, and what are these nodes. A blockchain ledger is resistant to changing data. The ledger records transactions between two parties, such as you and me if we were exchanging cryptocurrency, and the ledger does this in a verifiable and permanent way. When there is a change in the ledger, such as a new transaction is being made, the changes are distributed to all the nodes, which will verify and update their own copy of the ledger. A blockchain is immutable, meaning once a transaction is stored and verified by all of the nodes in the network, the transaction cannot be changed without changing all the previous and next blocks. This makes transactions irreversible. So blockchain transactions and their data are append only. You can't remove. Transaction reversal is extremely hard for the reasons just mentioned. Regardless of that, it still has been done rarely, and these attacks result in a loss of cryptocurrency if a blockchain is hacked. A person-to-person network is where each computer in the network is a node. The node maintains the records of transactions in consecutive blocks. The person-to-person network is also found in torrents, but a torrent network is not a blockchain. A torrent network is designed to share files only, but a blockchain is different. Blockchain enables transactions. A decentralized ledger is another name for a blockchain. They are called the same thing. Each node keeps the same copy of the ledger. A chain of connected blocks is the network. So each block is connected with a link and implemented with a record of the cryptographic hash of the previous block in each block. So that is what creates that link between each block, and that is the blockchain. It's a chain of blocks. You can visit the chain in reverse order, but the chain stores all of the blocks in chronological order. You may be thinking, what's the difference between traditional software that can process a transaction versus a blockchain that processes a transaction? Well, the answer is that blockchain solved a hard problem in computer science known as double spending. And that's what makes it different from traditional software. So let's talk about what is double spending. Well, when you share a document or a picture on the internet, something that is not money or a bond or a share, you are actually sharing a copy of the file. So you're not actually moving your document or your picture onto a website, you're instead copying it. The difference is with money or bonds or shares, we should not share them as a copy, because then it would be like forging money. You would be just copying money whenever you send it. If I were to send you $5, I'd be copying the $5, but then I'd still have my $5. So that's not really a transaction, that's just copying money. So that's why we can't share money, bonds, and shares as copies. So that is double spending. How do we make a transaction without making a copy? Via the internet. Because if we want to share something else on the internet, we're making a copy. But how do we then share money without making a copy? Well, we can do what's known as a value transfer, which allows you to share money without making a copy. And for that, traditionally, you need a trusted third party if you're not using a blockchain. These trusted third parties could be a bank or a stock exchange. This trusted middle party is centralized because it acts as the middleman to process transactions and ensure safety. And in this way, we can send money without having to have a copy. Now, the blockchain is decentralized, and it actually solves the double spending problem, because on the blockchain, you don't have to depend on any kind of intermediary trusted party. I can send the money directly from me to you. I don't need any kind of trusted middle party, and I still won't be doing a copy, because copying money would not be sending it. With the blockchain, parties can do safe transactions directly. And the way that the blockchain achieves this is with its decentralized network and its consensus algorithm. Bank or stock exchange trade servers are centralized. So this is the traditional way to send money, bonds, or shares. They are continuously attacked, and attackers can change the database and put in fake entries. So the bank or the stock exchange, although we're relying on it, it is prone to risk. And as well, there are many other negatives, cons, such as it's slow to do trades, there's a limited time, if it's the stock market, etc. And there's this middle party, I can't send my money directly to you. I have to go through my bank, or I have to go through the stock exchange. So the blockchain fixes that problem. And that is an introduction to blockchain. Coming up, we're going to do more thorough looks at the blockchain, decentralized networks, Ethereum, and Solidity. So join me coming up in our next lecture, where we will continue our introduction. Hello everyone, and welcome back to our course. In this lecture, we are going to talk about what are blockchains and distributed ledgers. So why should we learn blockchains? Well, they provide a good foundation for exploring the security of information systems in general. As well, blockchains highlight the importance of decentralization, which is a property of increasing importance in the design of modern information systems. As well, learning blockchains allows you to understand security critical components like key management, software security, privacy preservation, and public key infrastructure. As well, blockchains are changing society and organizations, and they will continue to do so even more in the future. So it is a great technology to get your hands on. What is a blockchain? You can think of a blockchain as a distributed database. It satisfies a unique set of safety and liveness properties. Let's look at a case study of money. There are several properties of money. For example, it's a medium of exchange. It allows you to exchange goods. And it's not a bartering system, which is where you trade actual goods. Money is the medium. And as well, the store of value of money is that storing and retrieving money maintains its value. So if I get $1 today, then I can rest assured that the dollar will still be worth something tomorrow. As well, with the property of money is that it's a unit of account. So we can price goods and services for accounting and debt recording. What about gold? Let's say we use gold as a way of making a transaction. So let's say we use gold as our money. The medium of exchange is average because we do have to carry it around. The store of value is bad because money, when it's gold, it can deteriorate. And even if it's not gold, let's say it's something else, like in the past people used seeds as money, and that definitely could deteriorate. Gold less so, but something that's more perishable can. So if we're using any kind of object, not just gold, as our money, it can also have unknown hidden quantities. For example, it's very easy to forge. That's why it's, as a unit of account, it's mediocre because it's forgeable. It's not that easy to divide if you have big hunks of gold, and it's fungible. Let's look at another case study. What if we use a bank as our money system? Well, the medium of exchange is good because it's trustworthy, it's secure. The store of value is mediocre because it is tied to the availability and reputation of the bank. As a unit of account, a bank is good because it's fungible and easily divisible. So whereas we can use a bank or objects like gold as money, with the blockchain, we're using a cryptocurrency instead as money. Let's talk about digital signatures, which are a key aspect of the blockchain. Digital signatures can be made by one specified entity only. They can be verified by anyone and they cannot be forged, so they have top security. That is the introduction to blockchain. Coming up next, we are going to talk about what are two cryptocurrencies, Bitcoin and Ethereum. So join me coming up in our next lecture. Hello everyone and welcome back to our course. In this lecture, we are going to introduce two cryptocurrencies, Bitcoin and Ether. So let's jump right in. First, we'll talk about Bitcoin. Bitcoin is a cryptocurrency. In fact, it was the first decentralized digital currency, otherwise known as a cryptocurrency. A Bitcoin is a digital coin that you can send through the internet, and you can have a wallet of coins. You can mine coins. You can also transfer coins among different accounts. You can buy things with Bitcoin if the company accepts Bitcoin. The advantages to using Bitcoin, a cryptocurrency, versus something like gold or regular money like the USD, the dollar, is that with Bitcoin, the transactions are person to person. So you have no middleman. You don't have a bank or a credit card in between the transaction. Sending Bitcoin is directly person to person. There's no middleman. As well, the fees are determined by a free market. Bitcoin is available to the whole world and you own your account. As well, there are no prerequisites or arbitrary limits, and you don't have to trust any third party. The source code is open source and you can see every transaction. To use a cryptocurrency, you can perform an exchange. For example, you can buy or sell Bitcoin for currencies like the US dollar. And you have a digital wallet to store your Bitcoins either on your computer, like on a website, or on a mobile app that acts as your wallet. And as well, you can perform transactions with crypto. To have a wallet, there are many different exchanges. For example, Coinbase is the most popular exchange. You can sign up to Coinbase for a free account and you can buy and sell cryptocurrency. As well, there's Kraken, CoinMama, Local Bitcoins. You can also exchange coins with friends, etc. An address is like an email address, and You can have as many addresses as you want, and this is how you can send and receive Bitcoin. You can send Bitcoin to someone by sending it to their address, which is a way to reference their wallet, and people can send Bitcoins to you via your address, and you can create as many addresses as you need. An Explorer is an easy to see way to see if your transactions are confirmed. So you can have an online blockchain browser that shows individual blocks and transactions, and transaction histories and address balances. So you can see if your confirmation was successful, if your transaction actually went through. There are explorers for Bitcoin and Ethereum. There are many different explorers. For example, for Bitcoin, you can go to blockchain.com/explorer. For Ethereum, you can go to etherscan.io. There are many types of explorers for different currencies, cryptocurrencies. Now, for development, you can build a personal local blockchain to test out your smart contracts, for example, which we'll be doing later in this course. One example of a local blockchain is Ganache. This is meant to mimic a public blockchain, but it's for testing, for development purposes. You can have instant mining, and a local blockchain is small in size. Another option for development is using a testnet where coins are separated and distinct from actual coins. The coins are fake, they don't have real value, but they are very useful for smart contract development because they provide different ports where you can deploy your contracts. Testnets are used for testing and experimentation. You can have different blockchain and Genesis blocks. For Bitcoin, there's testnet 3. For Ethereum, there's Rinkeby, Ropsten, and Kovan. There are many different testnets. For production, there is mainnet, where blockchains are immutable and irrevertible. And so when you finish your testing, you actually deploy it to mainnet. You can't simply update your code when it's deployed, so this is during the production phase when you've successfully built out your application. You can get test coins very easily, either via Ganache or in Remix. There are test coins for testing out your smart contracts. More on both of those topics later on in this course. You can also get test coins via websites. Like for Bitcoin, you can get Test Bitcoin, which is not a real Bitcoin, it's just for development, at tbtc.bitapps.com. And for Ethereum, you can go to faucet.rinkeby.io. Those are just two examples if you want to explore test coins. There are many other options for getting test coins. And that is an introduction to two cryptocurrencies, Bitcoin and Ethereum, the most popular cryptocurrencies. Coming up next, we are going to continue our theory, and we're going to learn what is a smart contract, because later on in this course, we are going to build smart contracts. So join me in our next lecture. Hello, everyone, and welcome back to our course. In this lecture, we're continuing our look at the theory of blockchain. We're going to talk about what are the properties of the Ethereum blockchain, which is one type of blockchain. Well, the Ethereum blockchain shares properties of decentralized and distributed networks. As well, the Ethereum blockchain makes use of cryptography to ensure the safety of transactions. One property of the Ethereum blockchain is that it is trustworthy. It's hard for attackers to change entries on transactions. Therefore, you can trust the Ethereum public mainnet. This is the public blockchain. You don't have to trust the party. If we're doing a transaction of coin, you don't have to trust me to send you the coin. You just have to trust the blockchain will get that to you. And you don't have to trust any intermediary. You only have to trust the blockchain. As well, the Ethereum blockchain is a distributed ledger. This means you have multiple nodes working together in a network, and that's known as a distributed blockchain network because the nodes are distributed. And these nodes share a common ledger, and this distributed ledger is what keeps records of transactions. As well, the Ethereum blockchain is attack resistant. So whereas banks and the stock exchange, they are constantly under attack, it's much harder to attack the blockchain. Blockchain doesn't have centralized control or any intermediary party. Attack resistance is instead done by miners, and miners use their processing power with nodes to guard against malicious attacks. And miners earn incentives in the form of coin to keep the network safe by behaving honestly. We'll talk a bit more about miners later on. As well, the Ethereum blockchain is available 24/7. It never stops processing transactions. Even if a node in the network breaks or corrupts or gets attacked, the blockchain can still continue. It won't completely shut down, so it's always running. It can operate safely up to a certain limit and continue processing transactions with running nodes if one of the nodes breaks. As well, as we've mentioned, the Ethereum blockchain has no intermediary, no third party or middleman. So the blockchain removes any kind of dependence on an intermediary. A transaction, like sending or transferring money, can be done directly between two parties, like you or me, or two systems, if you have a company. As well, the Ethereum blockchain is faster than traditional systems. Traditional banks can be slow. They need time to process transactions, especially if it's something like across a border or worldwide transaction. And if the bank is closed, etc., on the weekends, holidays, banks can be slow with transactions. The blockchain transactions are much faster. As well, the Ethereum blockchain uses a consensus protocol for safety. This consensus protocol is also called a consensus algorithm. It is an algorithm that ensures all nodes are safe. So we are ensuring that the nodes of the network are all ensuring network safety. An algorithm, if you don't know, is a piece of code that is specifically written to execute some task. Nodes use a consensus protocol or consensus algorithm to reach a consensus or agreement and discard blocks generated by attackers or by a bad node. So nodes are working on the verification of a block with an algorithm. And in this way, every node is helping to avoid system failure. As well, the Ethereum blockchain is transparent. Ethereum is a public blockchain network. There are private and test blockchain networks as well, but Ethereum also has the public blockchain. On this public blockchain, all of the transactions are public and transparent. This means anyone can see the balance and transaction history of any wallet at any time. You can do that just by using a block explorer. And as well, the Ethereum blockchain uses the proof of work consensus protocol. This is the type of consensus algorithm that the blockchain uses. So it's a form of safety insurance, verification insurance. So in this type of algorithm, nodes are competing with other nodes to solve a cryptographic puzzle. And so they have to solve a math problem. And these math problems are quite complex. The node that solves the puzzle first adds a new block to the blockchain. And this is known as mining. So if you successfully mine a block, it means you have solved the puzzle first. So the more miners, the longer it will take for you to earn your reward, which is a coin. When you do successfully mine a block, you earn a block reward in the blockchain's native coin. For example, it could be a Bitcoin if you're on that blockchain. And that is how miners are incentivized to keep mining. And this mining is what ensures the safety of the blockchain. There's also another consensus protocol known as proof of stake. This is the one Ethereum blockchain will use in the future. And this works slightly differently, but it's still for the same purpose of getting a consensus. It's still the purpose of the node to ensure the safety and the verification of a block. So in this type of algorithm, you have to put the native blockchain coin up for stake. So you put a coin for stake, and the protocol will select a miner randomly or according to coinage. And the miner is rewarded when the block that is added is valid. If you don't add a valid block, you can lose stake. As well, with Ethereum blockchain, you have ownership of your coins and your account. Your wallet is a piece of software that keeps private and public keys. So with your private key, you can access your account. With your public key, you can receive coin and more. With these keys, you make transactions. And with your wallet, you're in full control of your assets and your data. If your private keys are maintained by another entity, like a company or an application, then you don't have full control. But if you're directly using your wallet to make transactions without any other entity, then you do have full control. As well, the Ethereum blockchain has a lot smaller of fees for transactions, because with traditional banks, the transaction fees are high, whether that's just for regular payment or with a cross-border payment, some kind of international transaction, the fees just go higher. But with the blockchain, the fees are much smaller because there is no intermediary taking commission. So therefore, it's much more affordable to send payments on the blockchain. As well, as we've mentioned, the Ethereum blockchain is immutable, so you can't change or reverse transactions. Smart contracts as well are immutable, and smart contract code cannot be changed. They'll remain on the blockchain forever. Anyone can see a deployed smart contract as well. You can just put the contract address on the Block Explorer, similar to how anyone can see any wallet or any transaction that's ever been made. And data stored in the smart contract is immutable by the contract code. If you have another program that is specifically for storing the data, then you can change the data, but otherwise, you cannot change it with the contract code. As well, as I mentioned, the Ethereum blockchain is irreversible. You can't undo a transaction once it's been executed on the blockchain and confirmed. The reason for that is to ensure safety of value transfer, which, remember, value transfer means sending money without making a copy. As well, the Ethereum blockchain is chronological, so transactions are coupled and stored in a new block, and then the block is added to the chain via the link, and this is all in chronological order. And every transaction is timestamped, so you can prove whether or not a transaction actually happened at a certain date or time, and you can verify if the transaction happened and when. As well, the Ethereum blockchain makes use of cryptography, as we already mentioned, those consensus protocols. Generating wallets also uses cryptography, as does signing transactions. These use a type of cryptography known as asymmetric cryptography, specifically the elliptic curve digital signature algorithm. And if you're interested, feel free to look up these algorithms, and then you can read more about the specific cryptography techniques that the Ethereum blockchain uses. Transactions are packed with the cryptography algorithms Merkle tree and SHA-256 as well. And that is properties of the Ethereum blockchain. Coming up next, we're going to continue our overview of blockchain, and then later we will get into building projects. Hello everyone, and welcome back to our course. In this lecture, we're going to do a deep dive at a look at the Ethereum blockchain. So to recap, there are different types of blockchains. For example, the Bitcoin blockchain was the first blockchain, which is primarily for transferring Bitcoins without an intermediary. Then there's also the popular Ethereum blockchain. This is a generic blockchain that was built for writing smart contracts. And you can define the rules of trust with these smart contracts. So you can actually have your own custom rules. Let's talk about when you should not use a blockchain. Well, you shouldn't use the blockchain in your project as a means to replace your database, because it can get quite costly and slow to use a blockchain instead of a regular database if you don't necessarily need a blockchain specific database. As well, if you need your application or your software to have high processing power, if you're going to have a lot of users, a lot of items, a lot of memory, then you don't want to use the blockchain. If you don't require blockchain specific functionality. In summary, if you're not requiring any blockchain functionality, then don't use it in your project. The Ethereum blockchain is slow and it can't handle high transaction throughput. Throughput means the amount of data that's passing through the application. Therefore, it's not recommended to be used unless it's specifically required. As well, storage on the blockchain is expensive, which is why you don't want to use it as your database. Again, unless you do need blockchain functionality or blockchain transactions enabled in your application. If you do need blockchain transactions or functionality or features, then that's when you would use it. Let's talk about where blockchain is being used today. It's being used more and more daily. Number one, cross-border payments. Both companies and some banks are already using blockchain for cross-border payments because, again, it's faster to use the blockchain and cheaper to use the blockchain to perform these types of payments. As well, blockchain is used in decentralized cloud storage. So you can actually store private and public data on the blockchain. Applications like Google Drive and Dropbox, those are centralized, so they don't use the blockchain. This makes them prone to attacks, and also that means the companies that own those applications have full control of your files. You don't actually own your data. But with a decentralized cloud storage application, you can own your data because it's stored on the blockchain, so you have a lot more control. And as well, blockchain is used in decentralized computing. For example, you can rent out your computer's CPU power to a decentralized blockchain network via the internet, and you can make money that way because you're renting out your power to be used for the blockchain. Now, Bitcoin supports a scripting language to write small scripts similar to Solidity smart contracts, but there's a lot more limited capabilities of the Bitcoin scripting language because it's hard to write complex scripts and the language is not even Turing complete, which means it can't write loops, and transactions are slow. So instead, we have the Ethereum blockchain as an improvement. This is one type of implementation of blockchain. It was proposed in 2013 by Vitalik Buterin, by a cryptocurrency researcher and programmer, and it was released in 2015. This is an open source, public and decentralized computing platform. It gained popularity because of the ability for developers like you and me to write smart contracts. So you can program your own smart contracts and execute them on the blockchain. And that's exactly what we're going to do in this course. So with Ethereum, it really opened the ability for developers to use the full potential of blockchain's properties. With the Ethereum blockchain, transactions are processed faster than the Bitcoin blockchain, and you can write decentralized applications to run on the blockchain. So this could be, for example, a front-end website that takes votes, or a front-end website that takes in transactions that you want to perform, or any kind of website or application, and then you can use the blockchain to store data, to send transactions, etc. The Ethereum virtual machine is the runtime environment for smart contracts. Ethereum supports multiple programming languages for writing smart contracts. Solidity is the recommended one and the most popular one. Smart contracts are compiled and converted into Ethereum virtual machine bytecode, and the bytecode can be executed by the runtime environment. So you first have to write it in Solidity, then it'll be converted for you into a language that the virtual machine can understand, and then the smart contracts can be deployed. Ether is Ethereum's cryptocurrency. Its symbol is ETH, and Ether can be subdivided to a maximum of 18 decimal places. So the smallest value that Ether can be subdivided into is known as a wee, and this is to a maximum of 18 decimal places, so quite a lot of division. Ether is publicly traded on centralized and decentralized exchanges. Some decentralized exchanges are actually built on Ethereum with smart contracts themselves. Ether is also the fuel for the Ethereum blockchain network. It's what you use to actually pay for transactions because for every transaction, it takes some power, and therefore you have to pay for that work to be done. So for every transaction on the Ethereum network, some gas is consumed. So the manpower or processing power it takes to actually perform the transaction, it's known as gas. And so you have to pay a transaction fee to miners. And on the Ethereum blockchain, you have to pay that in Ether. And you can pay it in divisions of Ether like a Wii. All right. There are several terms for gas, like the gas limit. So you define this when you perform a transaction. This refers to the maximum gas that you are willing to pay for a transaction. If your transaction needs less than the maximum that you defined, then you'll get refunded the extra gas. But if your transaction needs more than the limit that you set, then your transaction will actually fail. So beware, because you will still lose some Ether. As well, when you're making a transaction, you will set the gas price. This is the price per gas unit that you're willing to pay for the transaction. So the more you're willing to pay, the faster your transaction will be processed. As well, Ethereum accounts can be externally owned or contract accounts. Both of these hold balances of Ether. And let's talk about these two types of Ethereum accounts. Starting with externally owned accounts. An Ethereum wallet can hold one or more externally owned accounts. These are accounts that you and I can own. You can create a wallet with different options like a wallet creation site or a browser plugin like the very popular MetaMask browser plugin, or with a mobile app. And a wallet is holding all of your accounts. So when you create a wallet, you're generating private and public keys with an account creation algorithm. The private key you shouldn't share with anyone. The public key you can share in order to receive coin. An account is a combination of private and public keys, and as long as you know your private keys and you're the only one who knows them, you are in full control of your account. The public keys you can use to, see different wallets using online tools, and as well to receive funds. Externally owned accounts, important to note, are not created on the blockchain. A contract account, however, is created on the blockchain. So a contract account is also just called a contract. This doesn't have any private keys. It only has a public address. And the code of a contract controls the flow of funds. So this is where the developer, you or me, we can set exactly what we want to be defined in our contract, what we want the trust to be, how we want the funds to flow, what we want the requirements to be. We can write that in the contract. With an externally owned account, a user can interact with deployed contracts on Ethereum. So you will write a smart contract as a developer, you'll deploy it on Ethereum, and then users can interact with that contract. And again, the contract account is created on the blockchain and is stored on the blockchain. And that is a deep dive into Ethereum. Coming up in our next lecture, we are going to do a bit more theory, a few more lectures on theory, and then we're going to jump into building out our smart contracts with Solidity. Hello everyone, and welcome back to our course. In this lecture, we are going to talk about what are smart contracts, because later on, shortly actually, we're going to be building smart contracts with the Solidity programming language. A smart contract, well, first let's talk about what is a regular contract. A contract is a legally binding agreement, and it recognizes and governs the rights and duties of the parties that signed the contract. A smart contract is a computer program where contract code is executed by all full nodes. The outcome of a smart contract is the same for everyone, and the code of a smart contract cannot change. So in that way, it's similar to a regular contract. With a Bitcoin program, a transaction refers to a transfer of value in the Bitcoin network. So we have input from which the transaction spends Bitcoins, and we have output instructions for spending the sent Bitcoins. For Ethereum, we have the same principles as Bitcoin. We have a peer-to-peer network where the currency is not Bitcoin, it is Ether. The global ledger is known as blockchain, and the blockchain has addresses as well as wallets, transactions, and blocks. Ethereum accounts refer to the global state of Ethereum. These accounts interact to each other through transactions or messages. So you can have an account and collect Ether via that account. Each account has a state associated with it and a 20-byte address, which is the account address. And that is an overview of what is a smart contract. Coming up, we are going to talk about what is the Solidity programming language. This is the language used to build smart contracts, and we are going to be using Solidity to build smart contracts in this course. So join me in our next lecture. Hello everyone, and welcome back to our course. In this lecture, we're doing an introduction to the Solidity programming language. This is just a quick introduction. Later on in this course, we're going to do a deep dive and actually code in Solidity. In this lecture, we're doing an overview of what is this programming language. Solidity is a high-level programming language used for writing smart contracts on Ethereum, and that's exactly what we're going to do in this course. With Solidity, we can compile the code for the Ethereum virtual machine. The syntax of Solidity is very similar to JavaScript, so if you have experience with JavaScript, that will help, but it's not required. We're going to learn Solidity from scratch. The contracts of Solidity are known as smart contracts, and they look like a class or an object. You'll see that when we code it out. There is static typing in Solidity, which means most types can be cast, and most control structures from JavaScript are available in Solidity. So if you're familiar with the JavaScript programming language, you'll have a lot of an easier time working with Solidity. If you have experience with any object-oriented programming language, that will also help you. But if you don't worry, we will explain everything from scratch. A pragma is a keyword in Solidity that enables certain compiler version features or checks. So at the top of a file that is written in Solidity, you'll often see pragma Solidity, and this specifies what is the language version of Solidity that is used or should be used to compile this Solidity code. Because as Solidity changes its language version, sometimes things change, and if you try to compile an old version of Solidity with a newer version of the code, then you might not be able to because Solidity has changed. So just keep a note that if you see the version of Solidity listed at the top of a contract, you'll want to keep that there because it means that the file is guaranteed to work. Variables in Solidity. A variable is like a container for data, and there are types of variables that we're going to learn how to build in Solidity. For an overview, a local variable means it cannot be accessed outside of its function. You create a local variable inside of a function, and you can only use it in that function. Variables have complex types, which are in storage by default, as well as value types, which are in the stack. And function arguments are stored in memory by default. As well, there are state variables, which are contract variables that are permanently stored in contract storage. You must declare them at compilation time. In Solidity, again, we have static typing, which means we must specify variable types. We have both value types and reference types in Solidity. As well, undefined or null doesn't exist in Solidity. This might be unique because in most languages, null does exist. In Solidity, variables that don't have a value will always have a default value depending on their data type. For example, an integer will always have by default 0 as its value, even if you don't assign it a value. And that is a quick overview of the Solidity programming language. Coming up, we are going to learn a lot more about Solidity, so don't worry if you didn't understand everything in this lecture, because we're going to do a deep dive into building smart contracts with Solidity. So we're going to learn Solidity as we build practical projects. All right, so join me coming up in our next lecture. Hello, everyone, and welcome back to our course. In this lecture, you are going to learn how you can build smart contracts online. We are going to be using the Remix online code editor in order to do so. All you have to do is go to remix.ethereum.org and you can instantly start building smart contracts. You don't even need an account. In this lecture, we're going to break down how to use Remix Ethereum. Let's start on the left-hand side. Here we have our left sidebar where we have different pages, starting with Default File Explorer. This is a window that shows you your workspace. So by default, you'll have a workspace created that has contracts, scripts, tests, and learneth, these folders. And these folders are meant to resemble an actual workspace. All right, here you can create and deploy contracts. For example, by default, you will already have 3 contracts created. Storage.sol, sol is the file extension for Solidity. Then you have owner.sol, a bit larger, and ballot.sol as well, even larger. So feel free to look inside of these 3 files for some examples of Solidity. We're going to be building our own examples from scratch because these examples can be confusing for an absolute beginner. All right, then we also have scripts, which we won't be touching, and we have tests, which allow you to test your applications. Again, we have a sample here. And we have learneth, which allows you to do some online reading if you're interested. All right, you can create a new file by using this file icon, just clicking that. You can create new folders as well. You can also connect to GitHub or upload files as well here into your file explorer. On the right-hand side is where all your code will appear. You can either zoom out on your whole browser or click inside of the code and you will zoom just the code. All right, next up in our left-hand side, we have the Solidity compiler. We have here the logo of Ethereum, and we have here Solidity compiler. So this is the compiler version that your code is currently using. You can just use the default one. If you experience any issues with the code that we're coding and your compiler, then just make sure you're using the exact same compiler, 0.7.6, because over time, Solidity can change and it may require that you use your old compiler in order for your code to still work. As well, you can select the language, Solidity, and your EVM version. We're going to use the default compiler for the Ethereum virtual machine. You can auto-compile, enable optimization, and hide warnings if you'd like. Anytime you hit this button or you hit Command or Windows S, you will save the file, which is the same as compiling it. If I hit compile for ballot test, that's going to compile that Solidity file and you'll see the contract will appear. And you can also publish the file and view details. All right, next up on the list here in this bar, we have deploy and run transaction. We'll go here often when we want to deploy a contract or test it out. So we have our environment. We're going to use JavaScript VM, but you can also use injected Web3 and Web3 provider as well. Then you have accounts here, which allow you to test transactions. These have some test ether, and if you want to copy the address of the account, you just hit this copy button. You can also sign a message. Then you have gas limit, the value, which is the amount you want to send per transaction. You can change this to ether if you want to send ether. Then here you'll select the contract that you want to deploy, and you'll hit deploy to send that to deployment. You do have to fill in any required arguments for deployment, and your value has to be 0 upon deployment time. You can also load a contract from an address if you have an already deployed contract, or if you have a contract at some address that you want to deploy. Your transaction count will be here, and your deployed contracts will be down there. So you can deploy a contract, and it will appear at the bottom here under your deployed contracts. And we're going to be deploying a lot of contracts in this course, so you'll see that happen. Then we have unit testing, our next icon in the left-hand side. So we can test our smart contract in Solidity using automated testing. We can select a directory to load and generate test files. All right, next up we have Learnith. This has some tutorials that you can read. And we have a plugin manager if you want to add any plugins. Make sure you have the Solidity compiler plugin activated. Otherwise, you don't need any plugins. But if you want to, you can add more plugins. To hide this left sidebar, you can either drag it like this, or you can just click on the icon to hide it. You can also close files just by clicking on them and then hitting the little X icon. Here at the home, you have featured plugins, resources, create a new file or open a file. You can connect to localhost or download all files. You can also close home and you'll just be taken to an empty page. All right, and that is how you can use the Remix IDE. And we also have this little bottom tab where you can search with a transaction hash. You can listen on a network optionally, and you can see messages. I can even drag that up if I want to see some console messages here. This is the console. There's also a little gear at the bottom left-hand corner. These are settings, so you can customize your settings. For example, you can generate contract metadata, which you do want on, and always use Ethereum VM at load. You want that on as well. You can enable text wrap as well. You can enable personal mode for Web3 provider, and you can enable Matomo analytics. You can also publish to GitHub, and you can select themes. So you can have a light theme if you'd like. Candy theme is quite fun. You can have different themes if you prefer light mode. All right, then you can also have at the top right-hand corner, you can see all the tabs that you have open. If you have more than one, you can open them in a drop-down. And those are the basics of Remix Ethereum at remix.ethereum.org. You're going to learn a lot more about Remix because we're going to use it for the majority of this course. It's a very easy online editor. It's very convenient. Makes it very intuitive for beginners to get started. So the Remix Ethereum IDE is a great tool, great resource, and it's completely free. You don't even have to create an account. All right, so now that you know how to use Remix, join me coming up in our next section where we are going to start building our first smart contracts right here at Remix.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.